In this lesson, you'll learn to find the inverse of a function or relation and determine whether two functions or relations are inverses. How are inverse functions related to measurement conversions? Most scientific formulas involve measurements given in SI, International System Units. The SI units for speed are meters per second. However, the United States uses customary measurements such as miles per hour. To convert x miles per hour to an approximate equivalent in meters per second, you can evaluate f of x equals x over 1 miles per hour times 1,600 meters per mile times 1 hour in 3,600 seconds, which, as you cancel, converts down to 4/9 x. To convert x meters per second to an approximate equivalent in miles per hour, you can evaluate f of x equals x over 1 meters per second times 3,600 seconds in an hour times 1 mile in 1,600 meters, which is the same as g of x equals 9/4 x. Notice that f of x multiplies a number by 4 and divides by 9. The function g of x does the inverse operation of f of x. It divides a number by 4 and multiplies it by 9. The functions f of x equals 4/9 x and g of x equals 9/4 x are inverses. Recall that a relation is a set of ordered pairs. The inverse relation is the set of ordered pairs obtained by reversing the coordinates of each original ordered pair. The domain of a relation becomes the range of the inverse, and the range of a relation becomes the domain of the inverse. Two relations are inverse relations if and only if, whenever one relation contains the element AB, the other relation contains the element BA. So 1, 2 becomes 2, 1, 3, 4, 4, 3, 5, 6, 6, 5. Q and S are inverse relations. The ordered pairs of the relation 1, 3, 6, 3, 6, 0, and 1, 0 are the coordinates of vertices of a rectangle. Find the inverse of this relation to determine whether the resulting ordered pairs are also the coordinates of the vertices of a rectangle. So all we have to do is reverse. Instead of 1, 3, we're going to have 3, 1. 6, 3 becomes 3, 6. 6, 0 becomes 0, 6. And 1, 0 becomes 0, 1. And they plotted the points on a coordinate grid, and notice that when we change from our original ordered pair was 1, 3 to 3, 1, it reflects over this line, which is the line y equals x. And the same is true for all of our ordered pairs. 6, 3 becomes 3, 6. So we can see that the inverse is also a rectangle, just reflected of the line y equals x. The ordered pairs of inverse functions are also related. We can write inverse of f of x as, and they write this f to the negative 1, it's read as the inverse of x. Suppose f and the inverse of f are inverse functions, then f of a equals b if and only if the inverse of f of b equals a. There's a pretty simplistic example from your book. They have the functions f of x equals x plus 2 and the inverse of f of x equals x minus 2. The opposite of adding is subtracting. So if we evaluate f of 5, we find 5 plus 2 is 7, or the inverse of f of 7, 7 minus 2, gets us back to the 5. Since f of x and the inverse of f of x are inverses, it's kind of redundant, f of 5 equals 7 and the inverse of f of 7 equals 5. The inverse function can be found by exchanging the domain and range of the function. To find the inverse of f of x equals negative 1/2 x plus 1, first I would rewrite f of x as y. Then we can reverse the x and the y. So I'm going to have x equals negative 1/2 y plus 1 and solve for my new y. So subtract 1 from both sides and multiply both sides by -2. And we get -2x plus 2 equals y. Or we could rewrite it back in function notation as the inverse of f of x equals -2x plus 2. Then they want us to graph the function and its inverse. Our original function had a y-intercept of 1 and a slope of -1/2, so we start at 1 on the y-axis and go down 1 over 2. The inverse function has a y-intercept at 2 and a slope of -2, so it's going down 2 over 1. And once again, we can see that the two graphs are reflected over the line y equals x. So it's a good idea to draw on that line y equals x when you're drawing your graph so you can see how it reflects. You can determine whether two functions are inverses by finding both of their compositions. If they both equal the identity function, I of x equals x, then the functions are inverses. Two functions, f and g, are inverse functions if and only if, so it has to go both ways. Both of their compositions are the identity function. So both f of g of x has to equal x and g of f of x must equal x. Determine whether f of x equals 3/4 x minus 6 and g of x equals 4/3 x plus 8 are inverse functions. It looks kind of scary because we have the fractions, but we know we're trying to get it to simplify down to x. So I just filled in the g of x function in place of x in the f of x function, and we distribute. So 3/4 times 4/3 is of course 1, and we have an x. 3/4 of 8, 8 divided by 4 is 2, times 3 is 6, minus 6 is, the 6's cancel out, so we get x, which is what we wanted. Now if I had something other than x there, I could have stopped because it already failed. But since we got half of what we wanted, now we need to go ahead and check both the compositions f of g of x and g of f of x. So when we do g of f of x, we're replacing x in the g function with the f of x function. Once again, the distributing is pretty easy because 4/3 and 3/4 are reciprocals. Everything cancels out. I have x. 6 divided by 3 is 2, times 4 is 8, plus 8. The 8's cancel out, and once again I get x. So I circled my x's because I had to get them, but I'm used to circling things after the equals. The final answer is actually the functions are inverses. I'm just going to mention in passing the one-to-one concept. They don't spend a lot of time with it this year. We'll get into it more next year. When the inverse of a function is a function, the original function is said to be one-to-one. To determine if the inverse is a function, you can use a horizontal line test. Now we already had the vertical line test, which tests to see if we have a function, and of course they are both functions. So in order to be a one-to-one function, you first have to be a function at all. To use the horizontal line test, we're checking the same way we did the vertical. So no horizontal line can be drawn so that it passes through more than one point. So the inverse of that function is a function. However, in this graph, a horizontal line can be drawn so that it passes through more than one point. In fact, there's a lot of places that it does. There's only one place where it only will cross through one point. Usually if it crosses at all, it crosses twice. So that indicates that the inverse of the function is not a function. In summary, reverse the coordinates of ordered pairs to find the inverse of a relation. Two functions are inverses if and only if both of their compositions are the identity function, so they both have to equal x, and a function is one-to-one when the inverse of the function is also a function.